converting. So this is a technique you can use if you don't want to convert to slope-intercept form, and you can still graph a line. Sometimes it's great, sometimes it's a little bit rough, but it's another option, and I'm going to show you how to do. So these are free-form notes today. Go ahead and put the title at the top, graphing without converting. The date should be underneath that. It's either the 22nd or the 23rd, depending on what day you have class. Okay, first heading, graphing without converting. As always with these things, if you want to fast forward or pause to write stuff down and then fast forward, it's fine. Make sure you look at the examples before you're done. If you have any questions, be ready to ask them in class. Okay, 1. Replace the x variable with 0 and then solve for y. Record the point and place on the coordinate plane. Okay, at this point we've got 1 point. The x value will be 0 because we decided that to be 0. And the y variable will be whatever we solve for. 2. Replace the y variable with 0 and then solve for x. Record the point and place on the coordinate plane. So this time we know the y is going to be 0, then we're solving for x. At this point we'll have 2 points to put on the coordinate plane, which in theory is enough to actually make a line. So use a ruler or other straight edge and connect the points and extend the line across the entire graph. So after you have your 2 points, graph it. I know I prefer to have more than 2, but 2 will actually work. So at that point, you can make your graph. Okay, on to examples. All right, so the first thing I'm going to do is plug in a 0 for x. So the reason we're using zeros is because it just cancels out. So 2 times 0 minus 4y equals negative 16. So you notice that just goes away, and I'm left with negative 4y equals negative 16 divided by negative 4. I get y equals 4, and since I plugged 0 in for x, I know that the coordinate plane, sorry, the coordinate now will be 0, 4. Okay, remember I know this because I selected 0 as my x value. All right, so this is actually the y-intercept. I'm going to go ahead and put that there. All right, there's my first point. Now I'm going to do the same thing, but this time I'm going to put a 0 in for y. For 0 equals negative 16. Once again, that cancels out. I'm left with 2x equals negative 16. I'm going to divide both sides by 2. I get x equals negative 8. I know my second point now is negative 8, 0. Remember, I know the y is 0 because I selected y to be 0. Okay, I'm going to put the point on the graph. Now I have 2 points. That's enough information to actually graph my line. And I'm going to go ahead and do that. So there's my line. I'm not sure why that didn't use a line tool, but that's fine. That's completely cool. So let's see if it's going to do it. Nope, it keeps on. That's fine. I'll do it this way. Okay, so I'm going to insert my line on my graph. I'm going to extend it all the way across on that side. Then I'm going to go ahead and grab that and extend it back. All right, so there's my line. Now, in this case, maybe a little quicker than converting it. No guarantee, just another way of looking at it. All right, so there's that first line. Okay, this was in standard form. We're going to look at one now that's in point slope form. So let me do this one in green. So this time I'm going to put a 0 in for x. So 0 plus 6 plus 1. So y equals half of 6 plus 1. Y equals 3 plus 1. Y equals 4. Okay, so once again, I know my first coordinate. It's 0, 4. Remember, I know it's x equals 0 because I am deciding that's the value I want it to be. So I'm going to go ahead and put that right there. Okay, now let's go ahead and put a second point on that. This time I'm going to set y as 0. So 0 equals 1/2 times x plus 6 plus 1. So 0 equals 1/2 x plus 3 plus 1. 0 equals 1/2 x plus 4. I need to get my x by itself, so I'm going to go ahead and subtract 4 on both sides. And I get negative 4 equals 1/2 x. I can cancel out the 1/2 by multiplying it by 2. 1/2 multiplied by 2 is 1/2 multiplied by 2 is 1, so that will eliminate. I'm going to slide it over just a little bit so you can see it better. So 1/2 x, if I multiply both sides of the equation by 2, cancels out and left with 1 over there. And then I'll have -8 on the other side. So I'll have -8 equals x. That will give me the coordinate once again, -8, 0. Now, if you're wondering, where do you get the 0, Mr. Robinson? Once again, I decided that I was going to plug 0 in for y, giving me the coordinate -8, 0. So I'm going to put that on the graph. All right, and I'm going to go ahead and insert my line. Okay, now you might have noticed that we actually are graphing the same line for both of these graphs, and that's perfectly fine. All right, now here's a downside. Let's say you pick an equation where when you plug in a 0 for x or y, you get a point that's like, let's say you're plugging in 0 for x and you get 0 and y is 1/3. Yeah, you can still graph it, but we're human, so getting that 1/3 on the graph in the right spot is going to be kind of rough. There's also a possibility that you could end up with something that isn't even a clean fraction. So as much as this technique will work and it will get you 2 points so you can make a line, it does have some shortcomings. So I want you to understand how the basics of how it works, but when ultimately, if you're not sure, convert to slope-intercept form. All right, if you have any questions, please ask them in class.